Imagine two galaxies, each with billions of stars, swirling clouds of gas, and countless planets hurtling toward each other. This isn't just a random event, it's a cosmic collision, one of the most mind-blowing phenomena in the universe. But what exactly causes galaxies to collide? And what are the consequences of this massive event? Today, we're diving deep into the science of galactic collisions, discovering how gravity, movement, and sheer size lead to these spectacular and sometimes chaotic cosmic encounters. To understand why galaxies collide, we first need to explore how galaxies exist within the larger structure of the universe. Galaxies aren't isolated. Instead, they are bound by a mysterious force, gravity, that holds them together in clusters. A galaxy cluster is like a giant neighborhood of galaxies, constantly interacting and sometimes even colliding with one another. With billions of stars and huge clouds of gas, these clusters play a critical role in shaping the universe as we know it. Galaxies are vast collections of stars, planets, and gases, all bound by gravity, which not only holds each galaxy together, but also sets them in motion within their clusters. Gravity is like an invisible hand that constantly tugs on galaxies, keeping them on a path that often brings them into contact with one another. This gravitational pull affects the speed, direction, and eventual fate of each galaxy. Gravity doesn't just keep individual galaxies together, it also influences their motion. Each galaxy's gravitational pull affects others nearby, almost like magnets. As they move, gravity gradually brings them closer together, increasing the likelihood of a collision over billions of years. Even though space is incredibly vast, galaxies don't always stay out of each other's way. They tend to form in groups or clusters where they're relatively close together by cosmic standards. So when galaxies get too close, gravity starts pulling them in until they collide. And when they do, it's not the chaotic smash-up you might think. It's more like a slow-motion cosmic dance that can last billions of years. Galaxies exist in neighborhoods or clusters where gravitational forces are strong enough to cause them to move toward each other. Think of clusters like communities, where galaxies are close enough to be affected by one another's gravity, making a collision much more likely. The science of collisions. What actually happens? When galaxies finally collide, the process unfolds over several stages. First, the galaxies approach each other, creating beautiful tidal tails, or streams of stars and gas that stretch out between them. Then, the actual collision happens, which isn't as violent as it sounds because stars and planets are so far apart. Instead, it's more of a graceful merging where stars are pushed into new orbits, and gas clouds crash together to form new stars. Finally, the galaxies merge completely into a single, larger structure. Stage 1. The initial encounter. As the galaxies approach each other, their outer stars and gas clouds start feeling each other's gravitational pull, creating tidal tails, a stream of stars that stretches out, almost like the galaxies are reaching toward each other. The gravitational forces between galaxies create tidal tails, which are streams of stars and gas pulled out by gravity. This stretching effect is due to the intense gravitational interaction between the two galaxies as they get closer. Stage 2. The impact. When the galaxies finally collide, their massive clouds of gas crash together. This compression of gas triggers an explosion of new stars, creating what's called a starburst galaxy, a galaxy in the midst of intense star formation. When galaxies collide, their gas clouds compress, creating high-density regions where new stars are formed in huge numbers. This stage is marked by a burst of light and energy from the rapid formation of stars. Stage 3. The aftermath. After the dust settles, the two galaxies combine into a new single galaxy. Often this newly formed galaxy is elliptical, a different shape from the original spirals, due to the gravitational reshuffling that took place during the collision. Once the collision finishes, the galaxies merge into one. The new galaxy often has a smooth elliptical shape, different from the spiral galaxies that collided. The stars and gas have now settled into a new structure that carries the characteristics of both galaxies. Why don't stars collide? Despite the colossal size of galaxies, their stars are incredibly far apart. So even in a galactic collision, individual stars rarely crash into each other. Instead, they're affected by each other's gravitational pull, which reshapes their orbits. Stars are spaced far apart, even within dense galaxies, which is why they don't collide during these mergers. The gravitational forces might alter their paths, but they're usually distant enough to avoid a direct hit. The future of our Milky Way. Our Milky Way is on a slow collision course with Andromeda, our neighboring galaxy. In about 4 billion years, the two galaxies will merge, creating a new structure that some scientists are already calling Milkomeda. This collision will transform the night sky and create an entirely new galaxy. The Milky Way and Andromeda are gradually moving toward each other. In a few billion years, they'll collide and form a single galaxy. This merger will change the appearance of the night sky as stars and gas form new patterns. The importance of galactic collisions. Galactic collisions don't just change galaxies, they play a crucial role in spreading essential elements, sparking star formation, and reshaping the universe. These collisions help create the diversity of galaxies and cosmic environments that may even support life. When galaxies collide, they distribute elements needed for star formation and possibly even life. These collisions also reshape galaxies, creating new environments and recycling cosmic materials. Galactic collisions are a powerful reminder of the universe's ability to create beauty from chaos. They transform galaxies, create stars, and contribute to the cosmic diversity that makes our universe endlessly fascinating. It's a cycle of destruction and creation that keeps the cosmos alive and ever-changing. If you enjoyed this cosmic journey, don't forget to hit that subscribe button and tap the bell icon so you won't miss any future videos from Cosmic Buzz-In. We're always exploring new wonders of the universe, and there's so much more to come. Also, join us on Instagram at @CosmicBuzzin. Thanks for watching, and remember, the universe is waiting to be discovered, one galaxy at a time. Until next time, keep looking up at the stars.